Solving by completing the square. All right, so as the name indicates, we are going to work with a square. And we're going to complete it in order to solve this problem. Okay, so this is just going to be a model we're going to use. It is not necessary when you get the hang of this, if this is a review for you to use this completing the square area model, but it's a nice tool when you're starting out or when you're just learning. So this particular problem is already set up with our x squared term and our x term on one side of the equation, and then our c value has been moved to the other side of the equation. So we're just going to leave it like this. And kind of the idea with completing the square is we are going to keep our equation balanced. So whatever we add to one side of our equation, we're also going to add to the other side of the equation. The other thing to keep in mind when we're solving by completing the square is this notion of, and I'm going to show it just way over here, that if you have x squared equals a number, that when you solve for that x squared by taking the square root, you get actually two answers. So x is equal to plus and minus 5 for this particular value. If you had something like, I don't know, 2x squared is equal to 72, then you would divide by 2 first. Okay, you would get x squared is equal to 36. And then when you take the square root, again, you get two answers. So x is equal to plus and minus 6 in this case. So these are just a couple of examples of solving when you have an x squared by itself and just a constant. The tricky thing about the perfect square trinomial is you have an x squared term and an x term. So you cannot go this route unless you just have an x squared and a constant, and then you can kind of solve in this fashion. So completing the square, what we're going to be doing is we're going to be adding on something to this side to make this a perfect square trinomial. So we're going to kind of figure out what that's going to be. I'm going to come over here and I'm going to throw my x squared into my model. And I'm going to take this 12x because I want the dimensions of this to be exactly equal. I'm going to cut that 12 exactly in half, and I'm going to put 6x in this box and 6x in this box. So that together, this is 12x, but when we think about what that means for factoring, and we've used our area model for factoring, that we know that the dimensions of this box are going to have to be an x plus 6 times an x plus 6. That's going to make them the same value. So we do need to add in or complete the square, right? This part is missing right now. So we need to fill it in with a number. And that number is going to be a 36. So I'm going to go ahead and add my 36. And of course, that's 6 times 6 is your 36 right here. And if I add 36 to this side, I get a little double plus sign going there. We don't need that. And then I add 36 to this side. I keep my equation balanced. The result is then 16 is equal to, and this perfect square trinomial can be written as x plus 6 times x plus 6. Another way of rewriting it from there is to rewrite it as x plus 6 times itself, or x plus 6 squared. And here's when we are going to kind of put into place this taking the square root. This entire expression is squared, so we are going to take the square root of both sides. What is left on this side of my equation is x plus 6. What is left over here is plus and minus 4. And this is where we're going to generate our two answers. We're going to rewrite this equation. One of the equations we're going to use a plus 4, and one of the equations we're going to use a minus 4. So it will look like this. 4 is equal to x plus 6. That is going to be one of our solutions. The other equation is going to be a negative 4 equals x plus 6. That will generate our other solution. So we'll subtract 6. Do a little algebra here. So we get negative 2 is equal to x. Subtract 6 from both sides. get negative 10 is equal to x. And there we have it. These are our two solutions, our two x-intercepts, our two roots of the function. Remember, those are all names for these x values where the quadratic crosses the x-axis. They're called roots of the function, they're called zeros of the function, they're called x-intercepts. All right, that should help. Excellent work on that one. All right, let's move on to one that's a little bit trickier. Not a lot trickier, but just a little bit trickier. There's a few additional steps to kind of get it organized. So when I'm faced with a quadratic, you have to make a choice. Do I want to use a quadratic formula? Do I want to factor? Do I want to try completing the square? One of the things that I always do before I even get started with making that choice is to look and see if I can make this a little bit more kind to deal with by actually just making these numbers smaller. Are these all divisible by a common factor? And in this case, I can see that in fact they are all divisible by 3. So I can factor 3 out of the first term, and that leaves me with x squared. Factor 3 from the 12, that leaves me with a minus 4x. Factor 3 from my negative 15, leaves me with a minus 5. And then when we're solving, and this is attached with multiplication right here, I can actually divide both sides by 3. 3 divided by 3 is just going to be 1. So I'm left with 1 times this value, which is just itself, and 0 divided by 3 is 0. So I've made the problem easier to work with. And again, at this point, you might choose factoring, you might choose quadratic formula. We are going to go ahead and continue with completing the square. So I'm going to go ahead and I'm going to move my c value to the other side. So I'm going to add 5 to both sides. And all I'm doing here is I'm kind of isolating my x squared and my x term. So we end up with 5 is equal to x squared minus 4x, and here's where I want to try and complete the square. Now again, you can use your area model. Another thing that you can remember is each time really what happens in your area model is you are taking half of your b value and squaring it. All right, that is the number that is going to get added to this side of your equation and over here to this side of your equation to keep the equation balanced. So let's try that with the negative 4. Let me see. Negative 4, half of negative 4 is negative 2. Negative 2 squared is 4. So it looks like what I'm going to be adding to both sides of my equation is a positive 4. Okay, so let's kind of keep going from there. It was nice to see the area model though, because one of the things that's nice about the area model when you have this x squared showing up right here and your minus 2x and your minus 2x is it's really easy to remember that, oh yeah, that negative 2 is going to be a part of my factors as I'm looking to actually factor this perfect square trinomial. And negative 2 times negative 2, of course, here was that plus 4 that we added to both sides. So what we have on this side of our equation is a 9 is equal to, and then on this side we have an x minus 2 times an x minus 2. Another way of writing that is 9 is equal to an x minus 2 squared. All right, so we're going to finish off over here, kind of on this side of our page. To get rid of that square root, or get rid of the squared, I'm going to take a square root of each side. So we get plus and minus 3 is equal to x minus 2, and remember here is where we write two separate equations. 3 is equal to x minus 2 will be one of our equations, and negative 3 is equal to x minus 2 is the other. As you add 2 to both sides, we get x equals 5. Adding 2 here, we get negative 1 is equal to x. So the roots or solutions for this problem are these right here. X equals 5 and x equals a -1. So there are a couple of examples of completing the square for you guys. Hope that helps you to be able to move forward with that process. All right. Have an awesome, awesome day. Let me see if I can get a good little smiley face here going for you guys. All right. Have a good day. Take care.